Hey YouTube family, this is Z from Crypto Shots, and today we are going to create a smart contract for savings account. Now this is gonna be the lecture 2 of our Ethereum programming language, and we'll be teaching Solidity for the beginners. So let's get started. Now before writing down the code, I would like to tell you a few things that in this smart contract that we are going to create, the code will be very simple. It is not a big code, but it is very informative. So with this, you will be able to tell that, okay, this is the savings account of mine in the blockchain. And if I want to withdraw some money, I can do that with the help of the smart contract in a decentralized way. Along with that, you can also tell the amount that you're going to withdraw as well as the time when the withdrawal will be successful, because you cannot withdraw your amount before the due date. So once the contract expiry will be there, or once the time will be hit, then only you'll be able to withdraw the amount, and after that you'll be able to transfer that amount to the account of the beneficiary or to the account of yourself, whosoever is going to take the amount from that account. But before starting down the code, I would like to tell you a few things that this YouTube algorithm demands likes and subscribe. So do kindly subscribe to my YouTube channel or smash that like button. So let's get started. Well, the first thing that we have to do is that we have to define the version of the Solidity that we are going to use. So we can do it like this: pragma Solidity. And just try to keep the version to be like 0.5.1, because Remix IDE, this web browser extension of Remix Ethereum, it supports the Solidity versions from 0.5.0, the higher versions of 0.5.0. So yeah, it's better if you define the Solidity version as this. Now after that, we are going to what will be there in our smart contract, right? So first of all, we'll create a contract for the account, right? I'll just give you the overview that what we are going to do, and then we'll code it accordingly, right? The next thing that we are going to do is that we are going to tell the amount, right? Then we are going to who is going to withdraw the amount, right? When we are going to withdraw the amount, right? And few more things, right? So first of all, we'll create a contract. So we can create a contract like this contract. Then we have to give the contract name. In this case, we will give the contract name as account, just for the simplicity's sake, right? So the contract is defined just like this. Now in the contract, what are the things that we require? First of all, we require the beneficiary, right? Whosoever is going to withdraw the amount from the savings account, he should be defined, and he'll be defined as a variable. We have three kinds of variables, data variables. The first one is local variable, the other one is global variable, and the last one that we are going to define over here is state variable. Now the state variable is permanently stored in the smart contract, and the local variable is defined just only for the contract. It won't be used after the contract or the function has been completed or the contract has been executed. So it won't run. It cannot be taken out globally. So that is the benefit. And we're going to define the local variable as well as the state variable. We can define the state variable just like this. So we are going to define beneficiary. Now I'll tell you, if you don't understand the meaning of string and public, you can check out my previous video as well, but I'll still tell you again what is the meaning of string. So string is basically a data type which will contain numbers as well as the characters. So mostly it contains characters. If you need to define numbers or integers in the Solidity programming language, then you can use the keyword as uint, right? But over here, what we require right now is we need a beneficiary, and we also require one more thing, which is the time. Now how we are going to define the time is, we'll take that unsigned integer, we'll create public because whosoever is executing the smart contract, he can give that contract as a input parameter. Also And Solidity provides us a getter function when we define any variable as public, so it will automatically fetch the data for that variable that we are defining, right? So we'll define it as u/56 and then we'll give the time name as release time. Okay, so release time is basically the time when the amount that is present in your savings account that will be released, right? The beneficiary is going to withdraw that amount, so that he or she cannot withdraw the amount at any particular time. He has to wait so that the block time hits the release time, and only then the amount that is there in the savings account will be transferred to the beneficiary. So this will be the purpose of this. Right now we have declared the variables, but in Solidity, if we want to execute these variables, we need to define them internally as well. So we need to initialize the variables as well. So we initialize the variables with the help of constructor, right? So constructor is basically a function that will always execute once. Whenever we'll run a smart contract, constructor function will be executed. It will initialize the value of the variable that we have defined. Now this is how we will define the constructor, and then we'll make it as public, right? But in the constructor, we need to define the state variables locally also. So how we can define these variables locally as a local variable? So we'll give the data type of the variable, and then right. So in Solidity, we define the state variable. If we want to define a local variable, we give underscore in front of that variable. The other variable will be underscore. Alright, u/int release time, and I've selected release time, but I need to give underscore before that, right? Release time. Alright, we'll make it public, and then we'll define beneficiary is equals to underscore beneficiary, right? We are defining both of these functions, just mapping them over here. Release time is equals to underscore release time. Alright, before going ahead, we need to define one more thing. Alright, so we have defined the name of the beneficiary. So we can give the name of the beneficiary just like this, equals to CryptoShots, yeah. And we need to define the address as well, right? Because we need to transfer the amount to the beneficiary, so we need to define the address. So we can define the address using this keyword address, and whenever we do transaction in smart contract or in Ethereum a virtual machine, we need, just like we define public, we need to define the address as payable, and then we have to give the beneficiary account, right? So I did a mistake over here that we do not want to denote it like this, because we have already given the name of the beneficiary. So instead of this, we need to define address as underscore beneficiary account.